Hey everybody, in this video we are going to be applying assorted right triangle trigonometry, and we have a problem where one missing side leads to us being able to solve another triangle, another triangle, and another triangle. So what I happen to have here, fairly direct, and maybe I'll even extend on this example, is I have two sides of this triangle. It's the only triangle that I have like two pieces of information beyond it being a right triangle. So you need at least two things. So I need either to know an angle and a side, or, well, you can't just know the angles, right? Because angle, not a thing. It's just similarity, not congruence. Can't figure out lengths, whatever. So let's start here and we'll work our way all the way around. And maybe, like I said, I'll add a triangle at the end. So 3, 4, first side we're going to find. Let's see if we can kind of go a little Roy G. Biv. So I'm going to use some markers here. The first side we'll find is this red one right here, okay? How long is that red side? Well, 3 and 4 are the legs of a right triangle. That could be our Pythagorean triple of 3, 4, 5. So 5. Got that. Now, next triangle, going to the orange marker. Orange. Now that I have 5, I can use that for another side in the picture. So, right there. So now that you know that the 5 is the red, let's just focus a little bit more, sorry. 5 is the red. What is the orange value? Hopefully we all said 13, because these are the two most popular, commonly used Pythagorean triples. So 13, brilliant. Next triangle. Next, well, we are so smart, so we see right here that we actually have these two sides are congruent. How do I know that they're the same? I have no idea if this is going to show up. I might have to trace over this. Ooh, on my end, looks pretty good on the screen, but I don't know how it'll show up on YouTube, so we might have to go over it. But you have in that triangle labeled a 45-degree angle. If you have a 45-degree angle, that means that this is also 45 degrees, which means you have an isosceles triangle. That means then this side is the same as this side. This is your classic 45, 45, 90 triangle, okay? 45, 45, 90 triangle. Now, guys, if you don't have in your brain by now the 45, 45, 90 triangle expressions for the sides that you learned in geometry and you're in pre-calculus, if you're in November of pre-calculus in any school anywhere, you have to know by now what the expressions are for the sides of a 45, 45, 90 triangle. There is no other way to put it. You have to. You cannot have to look it up. You have to just know it by now. Let's get it together, okay? So we are smart. We know it. I'm going to draw a little example. 45, I'm just drawing it, facing this way over here. 45, 45, 90. That means this side is what we know as x, x, and x root 2. Now, this is the way you're typically taught it in geometry. This is the way it's presented everywhere and anywhere, because we like to not have fractions as a part of our expressions when we can avoid it. However, this is great when you go from having a leg and you want to find hypotenuse. But what about in the scenario where you have the hypotenuse and you want to find the leg? Many of you will be fine. You'll say, oh, I'll just divide by root 2, rationalize my denominator, and be good with it. Some of you may want a bit of a shortcut. So if you have this side, which I will use the letter H for hypotenuse. So here, if we are given a hypotenuse, all right, if you're given that, you take the hypotenuse and you multiply it by rad 2 over 2. And what that does is it does what we just talked about here. It divides by root 2 to get it alone. So you solve for x, the leg, but it also rationalizes your denominator all in one shot. These are the exact same thing. If you can handle knowing this like fast forward version, then you know it. If you cannot handle that, you need to understand how to do it the long way. You have to know how to finish it. You have to rationalize your denominator. You have to understand all of that. So no one can know it for you. You have to know it, okay? So what do we got here? I had that this was 5. This is 13. If my 13 is the hypotenuse, then 13 root 2 over 2 is my leg. So 13 radical 2 over 2. Nothing to reduce. Cannot simplify. That's it. Next. Going with green. Green, I'm looking at this last triangle. I'm going to use this yellow, which we just said is 13 rad 2 over 2, to find that green side right over there. What kind of triangle are we looking at now? You may ask. Well, I'm glad you asked. You are now looking at a 30, 60, 90 triangle. Again, same speech. You got to know it, guys. You got to know it. Oh, that's not going to fit on the page at all, is it? Can I come back and do a mini triangle right here? Here you go. Okay. Here. So when you deal with the 30, 60, 90 triangle, here we go. If this is your 30-degree angle, I just can't fit it. My drawing's very small. If this is a 60-degree angle inside there, angle, 60-degree angle. It's not a 60-degree side. It's an angle measure. You need to know the difference between angle and a side. If you have ever labeled your angle on your side or your side on your angle, I hope you went for extra help because that's crazy. All right. So what are the expressions that you know and you don't have to look up and you're not lying to yourself then pretending you know? You use X for the shortest leg, which is across from your 30-degree angle. You have X radical 3 for your other leg. 3 on your other leg. X radical 3, because radical 3 is smaller than 2 and 2x is on your hypotenuse. 2 is larger than square root 3. 2 is greater than square root 3. Why? Because 2 is the square root of 4, and the square root of 4 is bigger than the square root of 3. So 2x radical 3 with the x, and then the x by itself is like a 1x, which is square root of 1, and that's the smallest. Boom. So that's what we got to work with. Now, if this side in yellow is 13 root 2 over 2, that side that I'm looking at in yellow is which side of my 30, 60, 90 triangle? It is my long leg. That side is 13 radical 2 over 2. It's also that side right over there. What do I need to do if I have x root 3? What do I need to do to get x alone? X root 3 is connected by multiplication. You're going to divide by root 3. So this is the other way to do it, like if you did it right from here. So if you say to yourself, x root 3 equals 13 root 2 over 2. This is doable. This is fine, but will some people mess it up? Of course. You divide by root 3. So I would just say put it down here. That makes more sense. It's a little more organized. Rationalize, and you get 13 root 6 over, that becomes 3 times 2, 6. And it doesn't reduce. But a lot of you aren't going to like that. That's fine. That's why I showed you another option. What's the other option, you may ask? Well, I'm glad you asked again. The other one was, if you are given, there's 2 other options, but if you are given your longer leg to start, yes, you could divide by root 3, but similar to this triangle, I could also get this side by taking the longer leg and multiplying it by root 3 over 3. Okay, and then that is still double the short side, so we'll cross that bridge when we get to it. So that's that right there. So again, if I just took 13 root 2 over 2 and multiplied it by root 3 over 3, because that part right there is 3. Hopefully we see root 3 would give us 3, yada, yada. We could jump right to 13 root 6 over 6. So 13 root 6 over 6. And then last but not least, maybe I'm not going to add on. I did enough other examples in the other videos, guys. I don't feel like dragging this one out longer than it needs to. So last we have our blue side. And what is the blue? The blue is the hypotenuse in the 30, 60, 90. And I'm not going to look at it from like that formula perspective, but more so from that one. I already have my short leg, which is this number here. So to go from x to 2x, you just double it. So when you double it, you can either double the numerator or cut the denominator in half. If you don't understand that, don't do something you don't understand. But let's do it out a little longer. So if I take 13 root 6 over 6 and I do times 2, do you do times 2 on top and bottom? Don't say yes. The answer is no, because it's 2 over 1. So could you go like this and write it as 26 root 6 over 6? You could, but I would say that's a little silly because you could reduce the 2 and the 6 to a 1 and a 3, and then 13 root 6 over 3. And that is the value we were asked to find for the problem X. You're welcome. So I hope you found that helpful. That is a classic multi-step problem. If you get the gist of it, great. You go ahead, you give the video a thumbs up. If you hate life and don't feel smarter and feel worse, put a thumbs down, write a comment, do whatever you gotta do, and pick a thumbnail. Keep it moving, keep on practicing. Don't just copy what you see on the screen and lie to yourself that you know it. Pause it and try it by yourself, and see you in the next video. Bye.